Okay, let's unpack this. Today, we're doing a deep dive into a fascinating stack of articles provided by you, our listener. This isn't just, a random collection. It's the first part of a series by an author named Ash.
Right.
And he's wrestling with, well, one of the hottest and, frankly, most emotionally loaded questions right now. Will AI take my job?
Ash takes a really foundational approach here, doesn't he? He starts right from first principles,
Yeah.
building up this very specific economic framework to try and understand AI's potential impact.
Okay.
And these first 10 articles, they really lay the groundwork for what he's planning to discuss further down the line.
So we're going to follow his logic.
We're going to follow his chain of logic, yeah. Break down his core arguments and just see what insights he pulls out in this initial exploration.
Right. So our mission: get to the heart of Ash's perspective, pull out the most important nuggets, understand his unique voice and style.
Which is quite distinct.
Definitely. And give you a shortcut to being really well informed on his initial case without getting, bogged down in every single detail. Let's dive in.
Okay, so Ash kicks things off right at the beginning, acknowledging the emotional weight tied up in that word job.
Yeah, he notes it's way more than just earning money. It's deeply connected to our identity, our place in the world.
Our purpose. Even.
Our sense of purpose, exactly. And he uses that as a kind of springboard to go back even further.
Okay.
Exploring what he sees as fundamental human distinctions. He highlights 3 key abilities.
Which are?
The ability to learn first, then using language to teach others what we've learned,
Okay.
and crucially, the ability to modify nature to create tools.
Ah, right. And he proposes that the process of doing this is indeed the widest definition of the word technology.
Yeah, that's a much broader lens than just thinking about, smartphones or computers, isn't it?
Absolutely.
And he emphasizes that these tools are essentially amplifiers or augmentations of our own abilities.
Like his hand axe example. His example of the hand axe is perfect here. It seems so simple, right? But look at the profound consequences Ash traces back to it.
Enabling hunting.
Enabling hunting, leading to cooked meat, which in turn freed up time from constant foraging. It's a small tool, but a huge impact.
And that innovation, the hand axe, it even named a whole period of human history.
It did. And Ash connects this drive for technological progress directly to competition and, survival.
How so?
He points out how Homo sapiens' ability to create better tools likely played a role in the fate of other hominids, like the Neanderthals.
Right.
And historically, societies with tech advantages have often prevailed. It's a recurring theme.
He makes this point very forcefully, doesn't he? Quoting him, "We cannot give up the inevitable demand for technological innovation lest we risk our very survival."
Yeah, it's presented as almost a biological imperative, like a constant competitive race we can't opt out of.
So how does he link this inherent drive for technology back to the economy? That seems like the next step.
He shifts gears slightly and proposes what he calls a technocentric view of the economy itself.
A technocentric view, what does that mean?
In this view, the economy isn't just about, buying and selling stuff. It's the sum of all resources and activities specifically needed to sustain that technological innovation.
So everything serves the tech progress engine.
According to Ash, yeah.
Yeah.
Ultimately, that's the core function.
And this leads him to his fundamental production equation. What does that look like in his framework?
It's pretty straightforward on the surface. Inputs plus processing a process.
Okay.
But the crucial part for Ash is that the output must have more value than the inputs and the costs involved in processing.
Right. The value add, that's profit.
That's surplus value. That's where profit comes in. Think of turning flour, that's your input, and labor, the processing, into bread, the output, that sells for more than the ingredients and effort cost.
Got it. And within that equation, Ash makes a very specific point about human effort, our labor.
Exactly. Labor is explicitly labeled as an input and therefore a cost in this equation.
A cost to be minimized.
Well, Ash argues that the fundamental goal of technological innovation, driven by survival and our needs and wants, is relentlessly focused on decreasing those costs for the same or even improved output.
Okay.
He characterizes this process with a very distinct phrase, something like, "This march of technology is inexorable and a one-way street." It sounds quite absolute.
It certainly does. And he gives a great historical example to illustrate just how dramatic this cost reduction can be.
Sending a message, right?
Yeah, sending a message over long distances. 1,000 years ago, it was a luxury only kings could afford, basically.
And today?
Today, sending a text or email across the globe is, as he puts it, practically zero cost. That scale of reduction is, well, mind-blowing when you actually stop and think about it.
It truly is. And this is the historical context Ash uses to frame AI.
Precisely. It sets the stage for how he sees it fitting in.
So where does AI fit into this powerful, cost-reducing, technocentric view he's laid out?
Ash frames AI simply as, but another tool. That's his phrase. An extension of human intelligence. So fundamentally no different from the Handex, just a different type of augmentation.
That's his argument. Fundamentally, he sees it as no different in principle from that first hand axe. It's an augmentation of a human ability, this time focused on cognitive tasks rather than physical ones.
Okay, so given that perspective, he shifts the central question we should be asking. It's not if AI will take jobs, but something else entirely.
Yes, he rephrases it. He asks, how will this latest technology improve the value the economy generates? And what would that entail as regards to the cost and thus prices of goods and services?
So shifting focus from the individual job to the whole system's efficiency.
Exactly. He's moving the focus from the micro level of my job to the macro level of the entire economic system's efficiency and value creation.
And based on this framework, he speculates about the potential outcome. What does he envision for costs then?
He suggests that if AI continues this historical trend of technology driving down costs relentlessly, we could potentially see production costs for basic needs. Think food, clothing trending towards near zero.
Near zero, like the text message example.
Making things like food and clothing resemble the cost of sending that text message today.
Yeah.
This is where he introduces the idea of potential liberation.
Liberation? Liberation from what?
From the necessity of performing labor simply to eke out a livelihood, which he notes often involves, quote, drudgery.
Okay.
He suggests that not having to give our time and effort will be liberating. But he's very deliberate in grounding this idea.
How so?
He adds, don't get me wrong, this is not a dreamer or an idealist painting a picture. He sees it as simply a logical extension of his economic equation playing out.
So it's his analytical conclusion, not just wishful thinking.
Exactly. It's where his framework leads him.
It's a powerful thought, isn't it? Grounding a potentially utopian idea in a cold, hard economic framework. And he really uses this foundation to build his case in the articles that follow.
Absolutely. He transitions from this abstract framework to the more concrete implications, immediately addressing the idea of inevitability.
Right. He circles back to that core point. A job can't be viewed in isolation. It's part of a much larger system, the economy, the relentless drive for innovation, production, efficiency.
And he uses that really memorable analogy for human progress itself. What was it, like riding a bicycle uphill?
You stop and you fall. Yeah.
That perfectly captures his view of the constant competitive pressure that demands innovation. You just can't stand still.
And this uphill battle has seen incredible acceleration recently, hasn't it? Especially in information tech.
Oh, massively. He gives that mind-boggling comparison. The computing power in our pocket today versus all of NASA back in the 1960s space race.
It's staggering.
This surge in computing power naturally leads to automating tasks. Cognitive tasks, particularly the routine ones, are being offloaded to AI.
While physical tasks go to robots.
While physical and labor-intensive tasks are being shifted to robotics. And he points out that AI is even playing a role in speeding up innovation in robotics itself.
So, Ash makes a strong case for why the shift to AI-driven automation is inevitable. What's his core reason? What's the driver?
It comes right back to the production equation. Costs.
Ah.
AI and robotics, for Ash, will simply become cheaper than human labor. Labor is a cost, remember.
Right.
And technology's fundamental function, in his view, is to reduce costs. So it's presented as an economic certainty within his framework.
He illustrates this with an example we've all interacted with. The ATM.
The automated teller machine, yeah. Think about the cost and convenience comparison needing a human teller for every single transaction versus just using a machine anytime.
It's a clear historical example, definitely. Technology reduced a specific labor cost dramatically and increased accessibility.
For sure. And Ash notes the human impact there. Human bank tellers often shifted to other roles within the bank, like customer service or sales. It wasn't just elimination.
But even with that shift, he leaves us with the big lingering question this inevitability raises, doesn't he?
He does. He asks, If air robotics is getting as good as or even better than human labor, what will we humans really do? He puts that question front and center, promising to tackle it later on.
Okay, so from establishing that inevitability, Ash moves into applying his framework to specific sectors of the economy.
Right, he brings us back to the production equation, inputs, processing, output, creating value, reminding us, again, with the flour to bread example, keeps it grounded.
And he applies this first to the food industry, agriculture specifically.
Yeah, pointing out that labor is a significant cost, even in highly industrialized farming today.
And he contrasts the costs.
He contrasts the ongoing expense of human labor salaries, benefits, time off, with the initial capital cost of AI robotics, which is then followed by much lower operating costs like electricity and maintenance.
Plus, machines don't need holidays or sick days.
Or go on strike, and they can work 24/7.
What's really striking, though, is his argument about productivity not just being linear.
Right. He argues that AI-based productivity isn't just about doing the same thing a bit faster. It has the potential for exponential increase, a step change.
And this isn't just about replacing existing tasks, is it? He talks about innovation.
Exactly. AI-powered innovation can enable much better ways of doing things. It might improve the inputs or the processing methods themselves, maybe finding better materials, optimizing growth cycles, or entirely new processes.
He mentions dematerialization here.
Yeah, he hints that dematerialization is a related concept he'll explore later, using fewer resources.
Okay. Then he uses manufacturing, like clothing production as another example.
Another area where reducing labor costs through automation significantly impacts the final price in what he calls a free market system.
Though maybe not down to practically zero cost, like digital messaging.
Perhaps not that low for physical goods, but he still sees a significant reduction in production cost as achievable.
Then Ash introduces a crucial distinction in the economy between goods and services.
Yeah, what he calls goods, physical manufactured items, often associated with blue-collared labor versus services, which are more cognitive, knowledge-based, often white-collared.
And he places his own writing in that services category.
He does. And here's where it gets really interesting and maybe a bit counterintuitive based on past predictions.
What's that?
Ash highlights a surprising trend he sees. Services automation is currently progressing faster than manufacturing automation.
Really? That overturns the old expectation that the physical, manual labor would be automated first.
Completely. That is surprising.
So what does he attribute this shift to? Why are services leaping ahead?
He links this shift, partly, maybe largely, to generative AI. He enthusiastically highlights ChatGPT specifically.
Why ChatGPT?
Because, as he puts it, this is the first time in all history that we have a machine that can convincingly speak like a human. That ability, that linguistic competence, unlocked a huge range of service-oriented knowledge work tasks for automation that just weren't accessible before.
Right, so the rapid progress in cognitive AI, like large language models, just outpaced the physical dexterity challenges that robotics still faces.
Pretty much. Although he does acknowledge that AI is now accelerating robotics innovation too.
Yeah.
So the physical side is catching up, but the cognitive side had this sudden breakthrough.
Okay. And he connects this to another concept, convergence.
Exactly. The concept of convergence, this ongoing trend of moving activities that used to involve physical components into the digital realm.
Like what examples does he give us?
He mentions quite a few. Shifting from paper letters to email, obviously, using CAD software instead of physical drafting tables in engineering.
3D printing.
3D printing, yeah, moving manufacturing design into digital files. And a whole range of medical applications, decoding genomes, predicting protein structures, simulating organs for drug testing.
Wow.
He even cites Ray Kurzweil on the long-term, maybe far-out prospect of mind uploading, and notes the very recent emergence of LLM agents that can mimic personalities for complex simulations.
So these trends were already happening.
Some started earlier, yes. But his point is that AI acts as a powerful accelerant for all of them. It speeds up this digitization.
Okay, so digging deeper into why services got ahead, Econ 05. You mentioned generative AI's language ability, but what else?
Well, he points out that software is fundamentally abstract. It's not bound by the limitations and costs of the physical world.
Meaning
experimentation is much easier, cheaper, and crucially, safer. You can tweak software code, run it, and if it crashes, well, it crashes. No harm done, usually.
Right, unlike retooling a factory floor.
Exactly. You don't have the significant costs or the real-world safety risks associated with reconfiguring a physical industrial plant. He highlights that our ethics prevent dangerous human experimentation, But the digital realm doesn't have that same physical constraint.
So you can iterate much, much faster in software.
Way faster.
Yeah.
And coupled with that is what he calls the near infinite replicability of digital artifacts.
The MP3 versus the CD example.
Spot on. Copying an MP3 file costs virtually nothing and is perfect every time, unlike manufacturing each physical CD. This infinite cost-free copying enables a rapid compounding enabler effect.
The standing on the shoulders of giants idea.
That's what he calls it, yeah. Code libraries, digital tools, they're instantly and perfectly reused and built upon by others.
And he attributes a lot of this collaborative building to the open source movement, right?
Yes, he sees open source as a kind of Creative Commons free market, where contributions are freely shared and reused.
And the currency.
The currency, as Ash rather amusingly puts it, is karma. It's this powerful engine for rapid innovation, particularly in software.
Makes sense. Any other factors?
He also mentions the advantages of remote work and collaboration in the digital world, which software development leans into heavily.
And hardware costs, obviously.
And of course, the decades-long exponential decrease in hardware costs Moore's law for processing power, Kreider's law for storage, general miniaturization. Ash makes the point that many older AI ideas weren't necessarily bad ideas. They just needed these hardware advances to become functional, to work reasonably well, and crucially, to be economically viable today. The hardware had to catch up to the software concepts.
Building on that, Ash dedicates more space to really hammer home how software ate the world in Econ 06, reinforcing those core advantages.
Exactly. Infinite replicability, easy experimentation, remote collaboration, the power of open source, all those things we just touched on.
And he introduces the concept of zero marginal cost in software. What does that mean in this context? How does he explain it?
It means that while there might be high initial fixed costs to create the software in the first place.
Right, the development effort.
Yeah, but the cost of distributing additional copies, one more user, 1,000 more users, is near zero.
Unlike making another car or another T-shirt.
Precisely. Contrast that with the ongoing material and labor costs of manufacturing each physical item. Software doesn't have that marginal cost per unit in the same way.
Plus, you get a perfect bit-for-bit quality copy every single time.
Yeah, no need for the same kind of physical quality control testing that physical goods require.
And the internet enables instant global distribution.
Right, which leads to things like software as a service, SaaS, really leveraging scalability and tapping into network effects.
Network effects.
Yeah, where the value increases as more people use it. Ash uses a rhetorical question to highlight the contrast. Think about a tiny team building an app that goes viral globally almost overnight.
Versus the massive infrastructure needed to distribute a physical product globally.
Exactly. The scale difference is immense.
And all this software usage generates something incredibly valuable in itself, data.
Absolutely critical. Ash calls data an economic asset, using that common phrase you hear everywhere. Data is thus seen as the new oil.
Why is it so valuable?
Usage patterns, user preferences, interactions, error logs. All this data is invaluable for refining algorithms, optimizing services, personalizing experiences, and crucially, training better AI models.
But data is different from oil, isn't it? In a key way.
Crucially different, yeah. Data is non-rival, meaning multiple people or systems can use the same data set simultaneously without depleting it, unlike a barrel of oil, which can only be used once.
Right.
This non-rivalry is key because it allows data to, as Ash puts it, beget new data. It fuels a cycle of improvement in machine learning and AI. More usage generates more data, which improves the AI, which leads to more usage.
A virtuous cycle.
Potentially, yes.
So software and data are fundamental drivers, but Ash also shifts focus to the crucial role of the hardware revolution that underpins all this AI progress, right, in Econ 07.
He does. He argues you can't understand the AI moment without understanding the hardware journey. He traces it way back.
Where does he start the story?
He gives a nod to the very beginnings of computing, mentioning Babbage and Lovelace's mechanical attempts.
Which he calls
a full century ahead of time.
the hell.
Then leading to the foundational theoretical work of von Neumann and Turing, and the concept of Turing completeness. The mathematical basis.
But the real practical leap forward came with physical components, didn't it?
Absolutely. The invention of the transistor was utterly revolutionary. And later the integrated circuit, the IC, the chip. Those were critical.
And Moore's law.
Ash emphasizes Moore's law, that observation about the doubling of transistors on a chip roughly every 2 years as a core driver of progress over decades. Alongside Kreider's law for storage capacity and general miniaturization, things just kept getting smaller, faster, cheaper.
He also references Ray Kurzweil's broader idea.
Yeah, the law of accelerating returns, which Kurzweil applies more broadly to the exponential growth in the price-performance ratio
Yeah.
across different forms of computation, not just transistors.
Okay. And a specific type of hardware development became pivotal for the recent AI boom.
Yes. The shift in importance from the CPU, the central processing unit, designed mostly for serial, one-step-at-a-time processing, to the GPU, the graphics processing unit.
Which was originally for games and visuals.
Exactly. But it was discovered, particularly in the 2010s, that GPUs, with their ability to do lots of simple calculations in parallel, were vastly superior for the types of computations needed for training deep learning models.
And companies like NVIDIA capitalized on this.
Hugely. NVIDIA played a key role in developing and promoting GPUs for AI workloads.
And how does cloud computing fit into this hardware picture?
That's enabled by virtualization, essentially creating software-based computers that can run on underlying physical hardware. This allows cloud providers to combine massive clusters of hardware efficiently and offer that computing power at scale in data centers.
So Ash's overall point here is that it's the combination of all these hardware advances, transistors, ICs, Moore's law, GPUs becoming AI workhorses, cloud computing providing scale,
That finally made AI, after more than half a century of trying painstaking research and multiple AI winters, truly viable.
right. He notes that earlier AI ideas weren't necessarily wrong.
They just needed this incredibly powerful and relatively cheap hardware foundation to actually work reasonably well in practice. The hardware finally caught up.
He then circles back to digitization and dematerialization in Econ 08 as a core trend powered by these software and hardware leaps and now turbocharged by AI.
Yeah, he brings it all together, showing how these pieces enable this larger shift. He uses some really striking examples here.
Like the word computer itself, that was memorable.
Right. He points out, bizarre as this may sound, the computer itself has been digitized, from a physical room-sized machine to effectively a software program running on a tiny chip.
What other examples does he use to illustrate this digitization?
Well, calculators becoming apps, entire office suites replacing paper, filing cabinets, mail rooms, messaging replacing faxes and physical letters, CAD and engineering replacing drafting tables.
3D printing, digitizing the making process.
Exactly. And then the vast range of medical applications we touched on: genomics, protein folding, simulating organs for drug testing.
And the more frontier ideas.
Yeah, connecting it to Kurzweil's concepts about uploading consciousness, and even the very recent emergence of these LLM-based agents that can mirror human personalities for complex simulations or interactions.
So digitization is turning physical things or processes into digital ones. What about dematerialization specifically?
Dematerialization means producing more economic value while using less physical stuff.
Yeah.
Getting more output from less raw material input.
And Ash links this trend
He
too.
links it directly to free market capitalism and technological progress. He even cites Andrew McAfee's work, showing that many developed countries are actually seeing peak or even decreasing consumption of certain raw materials because we're getting so much more efficient and shifting value to digital processes.
So he even connects this back to the concern about energy use in data centers.
Yeah, by framing it against the corresponding energy and material costs that AI is potentially replacing through this dematerialization process, you have to weigh the costs and benefits.
Huh.
He makes a point that AI has significant potential to turbocharge every such industry that has been or is being digitized and dematerialized, implying that while AI has energy costs, the alternative, doing the same cognitive work manually, perhaps with more material waste, might have even higher overall environmental or resource costs. It's a comparative argument.
Which brings us neatly to Ash addressing the costs of AI head on, especially that common concern about its energy-intensive nature in Econ 09. How does he approach that debate?
He really challenges the way it's often framed in the media. He asks, okay, AI uses energy, but what about the corresponding resource consumption of the non-AI alternatives?
You have to compare like with like.
Exactly. Compare the data center energy to the energy, resources, infrastructure, and human biological needs required for the human labor or physical processes that AI might replace or augment.
He breaks down the main costs of generative AI specifically, right?
He does, into two main parts. First, building training the massive foundational models. That's incredibly energy and compute intensive, costs millions, and is mostly limited to large organizations right now.
And second,
Running inference. That's the ongoing cost of actually using the models day to day, which still involves significant data center resources, but it's a different cost structure than training.
But his core counterpoint comes back to comparing these AI costs to human costs.
Yes, the cost of comparative human labor needed to achieve the same level of productivity, especially for cognitive tasks.
He uses that viral story of the PhD student, doesn't he? That's a powerful illustration.
It really is. Solving a problem that took a human expert a year, solved by an LLM in about an hour, that kind of potential productivity leap is hard to ignore.
And he broadens the comparison beyond just salary.
Absolutely. He compares the cost of AI providing, say, mid-level professional productivity to the massive societal investment in creating and supporting a human professional. Years of education, the physical infrastructure needed for offices or labs, transport costs, daily sustenance, healthcare benefits.
It adds up.
It really does.
Yeah.
He uses that rhetorical point that feels very characteristic of his style. Even without exact figures against each of these costs, it's not hard to see where I'm going with this. The total life cycle cost of enabling high-level human productivity is immense.
And AI has those other advantages we've mentioned, non-rivalry, easy copying, it doesn't get sick, works 24/7.
Right. Plus, he uses another analogy for the current state of generative AI.
Yeah.
He says it's like flight was in the time of the Wright brothers.
Meaning?
Meaning it might seem clunky, expensive, maybe even a bit unreliable now, but the underlying principles suggest vast potential for exponential improvement is there,
Yeah.
unlike the very slow pace of biological human evolution.
And he adds one more dimension to this cost discussion, framing it as ethical.
Yeah, he brings in the idea of AI as a potential democratizing force.
How so?
By dramatically lowering the cost of accessing intelligence or complex cognitive tasks, he argues AI can make valuable services, things like advanced medical diagnostics, scientific research assistance, basic legal advice, much more accessible globally.
Bridging the gap between rich and poor countries.
Potentially, yeah. He cites Andrew Ng, another prominent AI figure, on this point about democratizing access. And Ash puts the question directly to you, the listener. And that itself is worth the costs of running a data center. It really makes you stop and think about the value side of the equation, not just the cost side.
Okay, moving to the final topic in this initial batch of Ash's articles, Econ 10. He explores something he calls the free market of the Creative Commons. How does he set this up?
He starts by establishing the default in software. Code is typically copyrighted. It's considered intellectual property owned by its creator or company.
Standard practice.
Right. And then he introduces the open source movement as a counterpoint, spearheaded by figures like Richard Stallman back in the day.
What was their core idea?
Advocating for code to be free as in freedom, not just free beer to share, modify, and reuse. This is where the concept of copyleft comes in, as a clever twist on copyright.
Copyleft, meaning you can use and modify it, but any new work you create based on it must also be shared freely under the same terms.
Essentially, yes. It uses the legal framework of copyright to ensure ongoing freedom. It's rooted in common law systems and uses specific licenses like the GNU GPL or the MIT license to define these terms of sharing and reuse.
And the core mechanism.
The core mechanism is that freedom to share, modify, and reuse, but it's usually balanced by a requirement to give attribution credit back to the original creators.
And Ash uses the term Creative Commons for this whole ecosystem.
Yeah, he uses Creative Commons broadly to describe this collaborative space, and again calls it a free market, where the currency, that intangible reward, is karma or reputation. It captures the spirit of it.
So how does this open source philosophy apply specifically to the world of AI? What gets shared?
Two key things, mainly. Sharing the massive data sets used to train AI models, and sometimes sharing the resulting weights, the parameters that represent the trained model itself.
He highlights some key historical milestones in open source AI development, doesn't he?
He does. He mentions the ImageNet dataset, a huge collection of labeled images being made freely available, which was a massive catalyst for computer vision research.
And the Transformer paper.
And crucially, the publication of the research paper detailing the transformer architecture. That paper laid out the fundamental design that underpins most modern large language models, and it was openly published.
What about early language models themselves? Were they open?
Some important early ones were, yes. Ash points to Google's BERT model and even OpenAI's first GPT model.
Yeah.
Yes, of ChatGPT fame, as he puts it, were initially released open source.
Why was that important?
It was critical in demonstrating the potential of these architectures and allowing the entire research community to build upon them, experiment, and push the field forward much faster than if they'd been kept secret.
But Ash observes a shift happened, right? Things changed.
He notes that as these models became incredibly powerful and demonstrated huge commercial potential, some labs, including OpenAI with its later GPT versions, stopped making their biggest, most advanced models fully open source.
Understandable from a business perspective, maybe?
Perhaps. But Ash uses that memorable phrase, the genie was out of the bottle. The fundamental knowledge, the architectures, the earlier open models, they were already out there in the community.
And so he concludes this section on a pretty optimistic note for open source AI.
Yeah, he suggests that despite the massive data and compute resources needed for the absolute largest proprietary models like GPT-4, the sheer vibrancy of the open source movement means that open source AI models are catching up fast and are actually not that far behind.
And he indicates this open source versus closed source dynamic will be a key focus in his future article.
It seems so, yes. He flags it as an important ongoing story.
Wow, okay. So we've really covered some ground here. We've journeyed with Ash from his fundamental definition of technology and the emotional weight of job through his technocentric view of the economy and the production equation, leading to his argument for the economic inevitability of AI automation.
Right. Then we explored that surprising acceleration of services automation, driven by digitization, software advantages, and hardware progress.
We looked at the foundational role of hardware and data, his perspective on AI's costs versus the alternatives, and finally, these fascinating dynamics of the open source movement in AI.
It's clear that Ash really does build his arguments meticulously, doesn't he? Step by step. He lays out concepts like the production equation and that technocentric view.
And then applies them consistently.
Consistently, yeah. Using clear examples, the hand axe, the ATM, the messaging cost reduction to make the principles concrete.
And his distinctive voice definitely comes through.
Absolutely. Not just in his phrasing, the inexorable march or the karma currency, but in how he frames these huge questions and uses those analogies to make complex economic forces feel more relatable.
So hopefully this deep dive into Ash's initial 10 articles gives you, our listener, a much clearer picture of the economic engine he sees driving AI adoption.
And his unique perspective on why this automation is inevitable, perhaps in ways we weren't expecting, especially that faster pace in the services sector.
It definitely adds new layers to that fundamental question he keeps posing. What will we humans do?
Yeah, and maybe a provocative thought to leave you with, building on Ash's themes. If his framework holds, if the costs of producing goods and services really do trend towards near zero, because AI increasingly replaces human labor as a key economic input, how might we, individually and maybe as a whole society, need to redefine value, work, and purpose outside of that traditional economic equation that's so centered on labor for livelihood?
That's a huge question.
It is. Ash hints at potential liberation, but also new challenges. What might those actually look like for you in your own life, your community? Worth pondering.
Definitely food for thought. And remember, this is just the beginning of Ash's exploration of AI and the future of work. We'll be diving deeper into his future articles as he releases them.
Looking forward to it.
Thanks for joining us for this deep dive.